So the table we are dealing with is students. We have a student ID, last name, first name, not advisor, and the relationship rating. Okay. So if we are assuming that each student has only one advisor, then this should determine everything. Am I right? But then the student ID will be the only determinant, and which is already key. So then this table is not violating Boy's normal form. However, if you say one student may have multiple advisors, then this table will have violation. So if a student has multiple, advisor, one advisor can multiple students, then you're going to have a relationship like this. Student first ID determine first name, last name, and then student name, student ID plus advisor will determine relationship rating. But in that case, this determinant, student ID, will not be a key for the table. So then that table will have a relationship, will have violation. So that table has two possibilities. So what I think the correct one, I think I highlighted as B. And now let's look at the C. For C table, student ID, last name, first name, state, and the major. And that I don't think you have any problem, because student ID is the only determinant. If you know the student ID should determine last name, first name, state, and the major. Okay, so this C is not a problem. And the D, you have student last name, first name, state, zip code, and that is actually a violation, because we know that if I know zip code, I should know the city, right? If I know zip code, I should know the city. So, but the zip code is not a key. So D is a violation for sure. Okay. And what about E? E is student ID, last name, first name, state, zip, social security number. That is actually interesting one. So if you have a student ID, if you know student ID will determine everything else. So you have a table like students with student ID, last name, first name, and also social security number. So in that case, you have functional dependency like that, right? But the student ID is the key, right? So that's not a violation. And then you may also have a social security number determines that, first name, last name, and also social security number. So this is student ID, social security number is also key. So therefore, this table is not in violation. Okay. So only questionable ones will be B. So depending on how you assume that advisor, I should make an assumption here. Say one student may have multiple advisors. That is typical case, isn't it? So one student have multiple advisors, then in that case, the relationship rating will depend on both student and advisor. But each student has only one advisor, then in that case, everything will be determined by student ID. So this is select all questions. I think this is the questionable one. B is the questionable one without assumption. Okay. Anybody else had the same issue with this one? No?
I did. I selected E because I thought social security number would identify or determine Last name and first name.
Yeah, social security number does determine social security number determines everything else. If you know social security number, you know the student ID, you know the last name, you know the first name, and also you know the student state, right? So indeed, the social security number will determine everything. However, that will not violate the Boy Scout normal form though, because social security number is already a candidate key.
Got it.
Got it? Yeah. All right, anybody else has questions? So I'm going to check how many of you have these many errors on this. So I will maybe give a point back on this one. So this one, I think I have to change the question, make assumption somehow. So maybe it's just assuming something. Assuming the advisor has one student may have multiple advisors, then this B will be in violation. All right. Anybody else has a question? Okay, so no multiple choice questions. So now let's take a look at your hands-on questions. Mariana, you said you have a question about which one?
For number 2.
Number 2.
Number 6 and 12, I wasn't sure how to give employees $100.
Okay, so let's do that. So let's first of all log on to Oracle. I think I'm already recording, right? Sharing, okay. So let's go to SQL developer. Okay, log on. Oh, by the way, for next 2 weeks, I will be doing all online because I have 2 classes which will have exam respectively in next 2 weeks. So next 2 weeks will be all online. Now let's do question 2 first. Find the managers whose name ends with M. Okay, so you're going to say select. So there's no column called manager. What you're looking for is employees who are managers. From EMP, where first of all, job is manager, right? So that's how you're looking for managers, and also e name like ends with M. So single quote, percentage sign, and M, like that. Okay, so that should be nobody. That's possible. Nobody ends with M. Okay, so it does not matter. The result does not matter. I'm just looking for this, the solution. Okay, looking for this query statement. You may have a different set of data. You may have, the result of what will be different from person to person. And then you say number 6, give all salesmen $100 of commission if they have never received one before. Okay. So you're going to update EMP, set commission equals to 100. Okay. Well, com is null or com equal to 0. So, or salesman, sorry, salesman. So here, now you have to make sure the job is a salesman, but then we have to make sure that we are using right condition. Okay. So if I just stop here, if I just doing something like this, what does this do? So what this do is you give the people $100 commission to whom? To those people who have no commission. Commission is null, or commission equal to 0, but the job equals to salesman. So remember, when you have and or together, so in this case, we have 3 conditions, right? So com is null, com equals to 0, job equals to salesman. So you link it by and or. So if you have and or connected in like this, and will be evaluated first before or. So in other words, you're going to get this condition, these two combined first, and then you evaluate this or. So basically, the employee who have no commission, not commission, or those employees who are salesmen but have 0 commission. In either case, you give them $100. But that's not what that's not what the question asked. The question asked is give $100 commission if they have never received commission. So you need to give that to all salesmen. Give all to salesmen. So even though there's people who have 0 commission, is no salesmen who have no commission, you should give them $100. And these people, this commission, no commission case, if they are salesmen and also have no commission, then you give them. Okay. So what is the correct way of doing that is you should make sure that this is just a one condition to be evaluated together. So you put it inside a parenthesis. Okay. And then there's in your elementary school, you probably already forget elementary school stuff, right? So there's like called a p-das, right? P means parentheses will be evaluated first, and then you do exponent, and then you do p-das, and then what do you do next? You do d p-das parentheses. So multiplication will be done before plus minus, and then parentheses will be done first, and the exponent will be done next. So basically, so we are going to make this parentheses to be evaluated first, and then that after that we use and. So basically in this case we are saying that if for this, so first of all the people must be salesmen, okay, and they must have never received commissions. Is that clear? So this is just make sure that you use parentheses to surround these two conditions so that this all will be evaluated before end. Otherwise, you're going to get a wrong result. Okay, and then which one next? 11, you said?
6 and 12, but they're pretty similar.
6 and 12. Oh, okay, 6 to 12. Oh, indeed, pretty similar. So 12 is give those employees $100 commission if they never received before. So actually in this case, you do not need this salesman case. So you just get rid, you don't need this one. And then you don't need these parentheses anymore. Okay. All right, so because we are not specified to give $100 to those salesmen. So anybody who have no commissions, give them 100. All right. So just do a little bit extension for this case. So what if? So in this case, the people who have no commissions, we give them $100. Okay, that's fine. But what if people already have commission? For people already have commission. So for example, if I do something like this, so let's just say job equals to salesman. You know what's going to happen? So in this case, you are going to change for all salesmen. You are going to give them commission $100. Okay. What if people already have existing commission? They may have some other higher commissions, maybe 500, 200 commission existing. So this will not give them existing commissions. Instead, we'll override all their commissions to 100. Okay, so in that case, how do we make sure that we only give we give this we give commission, we add this $100 to their existing commission. So it's tempting to do something like this, right? So going to say com equals to com plus 100. However, in this case, we have another problem. So what if the commission is null? Null value plus 100 is null. Null is just to say, in the memory block, it's just like a whatever left over by previous program, previous SQL statement. So it's going to be garbage, and the garbage plus anything is going to be garbage. So any operation involving garbage is going to be garbage, right? So if the commission is null, then plus 100, then that will not, that's not going to give those people $100 commission. Instead, it's going to give them some kind of garbage, like null values, okay? So something like this, how do we handle that? And there's a way to handle missing values. So let me write it here. Okay. In many years back, I had a class. The students, they're pretty smart. So what they did is when they have those kind of situations, they change count to zero to null to zero. So what they did is they just, so what they did is this. They just update np, okay, and then say set com equal to 0, and then where com is null. Okay, so they changed existing commission to 0 if it's null. But unfortunately, this is not allowed. You cannot do this, okay? If you do that with your corporate database, then you're going to get a big trouble, okay? So null values exist because for some reasons, okay? So we know that, for example, when we do null, like Arc implementation, and we have to make sure that, out of these two columns, one column has to be null value, right? Has to be null. So you cannot just arbitrarily change null to 0, all right? Even that, but the idea is kind of right that when we do this, we have to make sure that if this count, we may change that to 0. So there's actually we can do that not really with physical database. So in other words, we're not changing actual commission to 0, but we can just change null values to 0 inside when we do calculations. Okay. And this is what we do. We can use something called MVL function to do that, okay? So MVL function, so for example, if I have a null, if commission is null, then that you can change, say this change to 0. So let me just write it here, okay? Right here. Write in the whiteboard. So, MVL, okay? So then whatever column value here, so this time suppose I have a commission column, okay? And then this MVL allows you to specify which value to replace the commission value if commission is null. So let's say I want to replace by 0. So essentially this will give you this. If com is not null, then whatever com will be. So if com is not null. However, if com is null, then this will change, this function will change to 0, okay? But that will not really change your actual database values, the column values. You are only just like, inside the cache memory to do these conversions, all right? So if we use that function, then this question can be solved easily. So what we can do is we can just say update enp set com equals to mvl com 0 plus 100, and then say say job equals to salesman. Okay, so that does not matter whether commission is null or not null, and you are going to get the correct result in either case. So if existing commission is like say 300, then this MVL, the whole thing will give you 300 and the plus 100. So that you basically give $100 additional commission to those employees. But if commission is 0, if commission is null or 0, then this will be, whole thing will be 0, and then 0 plus 100. So in those cases, you give just, give them fresh $100. So there's no, to replace existing no commissions. Okay, All right, so any other questions in this list? Yes or no?
I don't have any more. I don't have any more questions.
You don't have any more, so does anybody else has questions? If there's no more questions, let's move on to today's subject. So this week we are going to do two things. First, we are going to do multi-table queries. So we are going to learn joins. And then we are going to do statistic functions or group functions or whatever name we call it. So it's not that difficult stuff. So I will consider them as like intermediate stuff, intermediate SQL. Okay. So let me turn on today's weekly outline first. Oh, insufficient privilege. I need to log in first. Okay. So let's do join first. First of all, let's just do a couple of questions related to join. So whenever you use multi-tables, you need to join them. And I think we started on this last class. So let's say I want to create just like a simple list of department name along with their employee names, employee job. Say suppose I want to create a directory. Okay, so let's just write a question here. Create a directory. Okay, of employees, the department name, DPT name, employee name, e-name, and the job. Okay, just do that. So you're trying to do here, so say select department name, that's D name, right? And the E name, and the job. Okay. And then from, so this time employee table is not enough because employee table does not have department name column. So we need to have DEPT table to be in place. Okay. Now, if we're going to stop here, you see what's going to happen. So let's run that. And then if you look at the result here, operations, how many employees? 17 listed, right? And then accounting, how many employees? Also 17. Does everybody say this? What do we get in here? We actually get in something like a Cartesian product between departments and employees. So this will list every department along with every employee. So basically you get an arbitrary combination of every department and every employee. So if you have 10 departments, 100 employees, then you're going to get 1,000 of this. Okay? It does not matter that employee belongs to the department or not. Let me just put department number also. So let's say DEPT number. So if we use that's DEPT number. Now, if we use department number, then this one is going to be this query is going to be problematic because the department number is a column in EMP table and also in DEPT table. Do you see that? So they are not really, so it's going to be confusing to Oracle. So if you want to specify which department number it is, then you just add, for example, say DEPT number. So that means this department number is from here. Okay, and we can also add another column, say, let's say EMP.DEPT number. Okay, now if I do that, then you will see the relationship clearly. Okay, so you see that here, operations, department 40, and the Kim, president, department 10. So they do not have a relationship, this employee and this department, right? However, by using this query, you are getting everyone listed. And this is This is called outer join. Okay, so what is outer join? Your outer join is just Cartesian product of records from those tables. So it does not matter whether they have relationship or not. You basically just get each record from department table paired with each record from EMP table. Okay, so then you get like those kind of products. Is is a explosive product. Okay, so you can just imagine if those tables. So some typically in the production database, you may have many thousands or sometimes several hundred thousands of employees, and then department you may just like several, maybe tens or several hundreds maybe. Okay, but if you're dealing with customers, then you're going to have even more records. So customer table typically have like several million, right? Several million customers, and then if you're going to join customer table with, for example, another table like orders, okay? So then each customer can make like tens of hundreds of orders. So you can just imagine how many rows you will be creating by this outer join, right? So millions times millions, right? So that is huge number. So this is what outer join is doing, all right? So what we are looking for is the correct one should be that to make sure that this department number and this department number should be matching, right? So we will do, say, select, let's say DPD number. So I'm going to copy this one. Okay. Copy this. And what we need is make sure that this department number must be matching this department number. So primary key, foreign key, they must be matching. Okay, so DPD number must be equal to EMP.DPD number. Okay, so if we do that, then you will get a much smaller set of result. Okay, and so you're going to get only like 15 key in this case, because you are matching each department with their corresponding employees in their departments. So now Kim belongs to department 10 and Jones belongs to department 20. So you're not going to get a arbitrary list like a previous one. So this is called inner join. Inner join. However, this inner join is implicit. Okay, but the starting point is still this one. So in other words, when you create this one, even though the result is much smaller, however, it will start with this outer join first, and then use this last condition to filter those records that do not have department number matching out. Does it make sense? So for example, if you want accounting paired with another employee who does not belong to accounting, then that record will be excluded, will be filtered out. Okay, so this implicit join, in a sense, you get much better, better result, and the result make more sense. However, it still starts with this one. So in other words, if you're going to do this so-called implicit join, you will actually start with outer join first, and then from that, a huge temporary result to filter what you need finally. Okay, so in that sense, this is not very efficient. Not very efficient, because you need to have a huge server memory to hold the temporary result. So just imagine if you have 1 million customers and with like 10 million orders, you combine them. So how large is the temporary space you need? So this is not a very good way of handling multi-table queries. But before 1999, this is the only way we can join tables. After 1999, the standard has changed. I think there's new, since then there's new join statement, explicit join coming up. So this explicit join. And this explicit join is to create a temporary table from multiple tables using joins. Okay, so this joins include, so there are quite a few joins listed in my chapter, but I'm going to just show you 3 of them, important ones. So one is inner join, and then left join, and the right join. Okay, right join. So other ones just work in the same way, but just basically you need to understand the different syntax, the difference a little bit. The syntax will be similar. Okay, just need to understand the difference, the meaning, the different meaning. So let's talk about the join, the different explicit join here. So let's say we have, just suppose I have 2 tables. Okay, table A, which may have a bunch of columns. Okay, so let me say we may have like X, Y, Z, and then we have table B. Okay, and then which may have U, V, W, those columns. All right, and then let's say we need to use a join to combine combine records from those 2 tables into one temporary table, and from which we can do SQL. Okay, like we can just do search for results, or do summary, or do statistics, whatever. Okay, so what is inner join is this. So suppose you have records A here, or this is all records A, and then you have all records B here, this set. Okay, and this set means those are the records that in A and B they are matching. They are matching. So the matching based on certain criteria. For example, you may have like a primary key, foreign key, primary key of A, and the foreign key, the primary key is duplicated inside of B as a foreign key. So those values are matching. So those are matching ones. Okay. So if we're going to just get data from A and B so that they are matching, then we are doing inner join. So this part we are doing inner join. Okay, and the syntax will be this. So you still select, and then after select, you can have a columns from either A or B, or maybe the expressions. Columns from A or B, or maybe there's expressions of these columns. Okay, just like what we did with one single table, and then say from. And this from will be, you're not from one table, you're not from 2 tables. Instead, you're from one temporary table created by join of these 2 tables. So the syntax will be say A inner join B, and then you specify on which conditions they are matching, right? So then you have a criteria here, or condition here. So use those conditions to join A and B. And then those matching records, only those matching records will be selected. So that is an inner join. Does it make sense? Good. Now what about other joins, like a left join, right join? So again, you still have, set of records A and a set of records of B. Okay, so there's all A records, there's B records, and those records will be matching records. Okay, so they have a matching. And then what about this one? Those records, you take from A, but there's nothing from B. There's no matching records. And then if you're trying to find all this, okay, and also there are matching ones, then use left join. left join. Okay. And what happens in that case? In that case, if you just suppose I'm going to get all X, Y, Z columns, okay, say X, Y, Z, okay, and then also U, V, W, okay? And then for each record of A, you have two possibilities, right? One possibility is that you have a matching records here. So if that case, you just list those matching records along with that. So if you have multiple matching ones, then you just need to, just reproduce the same XYZ record with those multiple matching records. Okay, but then what if you have one record here belongs to A but does not have a matching records? So in that case, you will just leave this as missing, no, no, and no. So make those records, this part as missing. So in other words, the left join will be concentrated on the left side table and you're trying to get every record from left-hand side table. And then if there's any matching record from right, then you just put those on the right, filling those columns belong to the second table. If there's no matching ones, leave them empty. Okay, and the syntax will be very similar. Just say, for example, if you say select X, Y, Z, or U, V, W. So those are the columns from either A or B. And then then you say let table A, left, join, B. And then you say on, and then you put a criteria here, conditions here, okay? And then the criteria will be deciding whether A and B have matching records or not. Okay, so the result is going to be something like this. And the right join is kind of similar, but just looking at the right-hand side table as focus. So let's say we have A table and a B table here, okay? And then if you use the right join, say A, right, join, B. So on certain criteria. So in that case, B will be the focus because you're using right join. B will be focus. So every row of B will be listed. Every row or every record of B will be listed. Does not matter has matching A or not. If it has a matching, list those matching records. If not, leave A's record corresponding data as missing. So in a sense, it's just opposite of left. Okay. So now let's try to use a few examples to demonstrate this concept of join, and then we'll be using join concept in some other examples also. So let me, I have an example here. Okay. Say find the employees and then matching department names. Okay. So I will just copy that and put into here, and then we'll write a query. Okay. So find the employees and then matching departments, right? So I'm going to say select E name. Okay. What else we need? Department name, department names, right? D name. Okay. And then say from. Okay, and then we do joins. So DEPT, inner join, EMP, and on. So the criteria in this case is basically we are looking, make sure that the primary key values is equal to foreign key values. So in this case, we're finding matching records here. Okay, so we are using inner join. Does not matter which one goes first, this one or that one, which one goes first. So, by the way, when we come back to this one, we'll do this implicit join. Doesn't matter which table should go first, DPT table or EMP table, which one goes first. Theoretically, there's no difference. However, practically, there is a small difference in terms of efficiency for running the query. So to improve your running efficiency, you should start with smaller table first, and then larger table next. So in other words, between DPT table and the EMP table, DPT table is smaller than EMP table, right? So it should so for performance consideration, we should start with DP table first, and EMP table next. You understand that, right? You understand that because your company definitely have more employees than departments, right? So department table should be smaller than that. Okay, is that clear? So here, so we are using inner join. Really does not matter which one goes first theoretically, but I think if you do a smaller table first, it should also improve a little bit efficiency here. Okay, so now let's run this. That should give you the same result as this one, same result. But this one did not show department numbers here, so we can show department number also. So let's say EMP.DEPT number, and then DNAME. Or we can actually do just trying to make the same model here. So let's do that. So DEPT.DEPT number, and the DNAME, and then comma ENAME, and then DEPT, and then EMP.DEPT number. Okay. So I know that because these two columns are the same, so you really don't need both, right? But just trying to compare the result here. Okay. So let's run that. So you get exactly same result as before. This time, this query will be much more efficient, much faster to run if you have larger tables, larger DPT and larger EMP table. Okay. There's another difference, another significant difference. That is, in this case, you are constructing the outer join first, huge table. Okay, and then you're trying to filter out some rows from that outer join result. Okay, but here you are just using join to create a temporary table before you do any where clause. Okay, so there's actually in this case there's no where clause. There's no like conditions for selecting which rows to be selected, but we can have that. But here we just show you that this is actually like a temporary table. The entire thing join create a temporary table. From that temporary table, we select in those columns. Okay, so for example, if I want to find out let's just trying to use this to do a question here. Find employees located in Dallas. Okay. Okay. Now let's say we could do implicit join, but this just say we will do inner join this time, explicit. Select employees, so ename. Okay. And then maybe we also put that location in here. From, so we are going to we need the information from EMP table, and also location is coming from department table, so we should join them, right? So DEPT, inner join, then EMP on same criteria. Number, also EMP.DEPT number. Okay, and then we can have where clause. So where location equals to Dallas. Okay, make sense? So those are the employees who are located in Dallas. Okay, now let's try to do left join and outer join to demonstrate, to show the difference. So this time, let's see, we'll do this example 2 here. So make sure you put your hands on, okay, just follow me to do the exercise. From today on, actually, I'm going to do 1 or 2 examples, and then I'm going to give you few more exercises and ask you to do it yourself, okay? So this one, find all employees' names and their department names, regardless whether the employee has a department or not. So that means we are trying to find all employees. And then if the employee have matching department, I show the department names. So in other words, okay? So we should use left join or right join, right? So we do select, ename, dname. Okay, so we should focus on EMP table, and then we choose left join. Make sense? Left join, and then the PT table. EMP.dpt number equals to dpt.dpt number. So remember, we basically need to get all employee records. Okay, that is our focus. And then if there's any matching departments, we list those department names. Okay. I think that should be it, because that left join will get all the employees records and also their departments if they're matching ones. Okay, and run this, and you'll see that this time you'll get different result. The result here, say Lisa, right? This Lisa. This Lisa has no department. So, but this, because they belong to employees table, and even though this Lisa does not have department, but because we are using left join, so we still show every employees. Okay, show every employees. So right join should be similar. Let me do just one more example, simple example. So this time we find the department names and the employees' names, regardless of whether the department has employees or not. Okay, so that means we should consider department as the most important source of information, and then employee will be like a secondary information. So I will do left, right join this time. Select D name and then E name. Okay, from. So we should use department table as the primary focus. Okay, so let's use right join. So I'm going to use EMP right join and then DEPT. Okay, so when you do right join, the right table becomes the focus, primary focus, and then the left table would be secondary focus. Okay, and then on criteria, that is the PT. The PT number equals to EMP PT number. There we go. Okay, so this time you should expect that all department names are listed, along with the matching employees, if there are any. Okay, so department accounting has a King, research have Jones, Ford, Smith, sales have those. Let's say operations has nobody. Operations has nobody, right? So that means so all the department names are listed. However, for employees, only matching employees will be listed. If no matching employees, missing values will be used. Does it make sense? For joins, left join, outer join. Okay, so if there's no questions, then we are going to switch topic. We are going to do statistic functions. So let's just have a basic concept first. Create a new slide here, a new whiteboard. So statistics. So basically, statistics. So sometimes we call them as group functions. Group functions. So it means that we have functions that apply to a group. Okay. Statistics is really just like a group functions, right? So for example, we're trying to find the max of some kind of data, or minimum, summation of some kind of data, or count. You know the difference between sum and count, right? Sum just add numbers, just count how many, 1, 2, 3, right? What else? You can also do average, AVG, average, okay? You can also do variance. You know variance, right? Variance just measure how data spread it out. So spread out from mean, from the average, okay? So if data more spread out, then the variance is going to be high. And if our data hugging around mean, very close to mean, then variance is going to be small, okay? And then the square root of that is a standard deviation as STD EV, I think, okay? You can also create some other functions. Okay, you can actually create your own, like using PSQL code, create your own customized functions. So anything that you do with, I don't know which program, which program you are using. So, for example, in some of our classes, some professors teaching jump, okay, or some people may teaching like a Minitab. I don't know which one you're using, and then SPSS. Okay, SAS and R. So those are more powerful environment. And the SPSS is good, and those just low-end statistic package, right? So when you use those those packages, so basically you're dealing with the tables, right? A table have multiple rows, multiple records, right? So this is like a case 1, case 2, and there's a case n, and then you have multiple attributes, right? So let's say this is column 1, column 2, and then this is a column m, for example, right? So when you use statistics, you're usually dealing with just one table, right? And then applying those using some kind of statistical procedure to calculate some kind of numbers, right? So the numbers could be simple as like a max, mean, whatever, right? So essentially, when we use SQL, we can do almost anything like those, okay? So we were just writing one SQL statement to obtain all these functions to get the result of this. So in other words, we are using live data to do statistics, and this is called OLAP, Online Analytical Processing, okay? Which is important because before data dumped to warehouse, you're trying to get some kind of a sense of some kind of knowledge about your existing transactions. So you probably want to run those OLAP programs to analyze existing data. Okay, so what you would do is you just simply select. Okay, you select and then use those group functions. Select the stat functions. Okay. And then you need to specify a table. So of course, in statistic package, you're dealing with only one table. But of course, you can always do, just do some kind of pre-processing, make all one table to be combined, somehow. But here we will be able to do it online. We'll do it on demand. So we can use a joined tables. So we can create a temporary table that is joining multiple tables. So we can do multiple tables at one time. Okay. So in statistic package, you also have a capability of selecting cases. So say I want to do this analysis, but I want to select certain cases. Not all cases are involved in calculation. So to select a case, you will use where clause in the where clause. You select your SQL statement. So you're going to use conditions here. Okay, so that will be used for select case. Okay, so that capability can be easily done by SQL too. And then in some advanced statistics like factor analysis, you're trying to analyze those data statistics by putting those cases into different groups. For example, all male observations or female observations. All right, so trying to compare the differences, trying to compare the mean values. Okay, or you can create more groups. So maybe you can just say male and senior, male, young, and the female, senior, female, young. So you can create 2 factors. You can have multiple factors. So what does this do is basically you are putting those different cases into different groups, and then calculating their statistics. So we can do it here easily also. We can just use so-called group by, okay? And then after group by, you can use those column values. For example, gender column, male, female, right? And you can have multiple columns. Say I want to use department and also columns and gender. So in that case, we're looking for female employees in each department and male employees in each department. So we can group those employees based on gender and also department. Okay, so we do group by, use group by clause. Okay, so essentially we can do all the simple statistics that that is obtainable from this simple statistic package using just simple SQL statement. Okay, and that's what we're going to do today. Okay, so we're going to start with just three steps. First step, I'm going to just do no selecting cases, no case selection. So essentially, we are using all data, all cases for doing statistics. Okay, and then we do select cases. Next. Okay, so in that case, we are going to use where clause. Okay, and step 3, we are going to do factor analysis. Factor analysis. So in other words, we're going to use group by. Use group by. Okay, and after that, we can actually, based on the group, we can select groups or select factors, select factor levels. So for example, certain group have certain characteristics. We're trying to find those groups. Okay, so we'll step using this 4 step to perform these examples. So let's start with simple ones. Okay. All right. Does anybody have questions? If no questions, let's just start with simple statistics. Get familiar with statistic functions. Okay. First, let's try to find how many employees are in the department. Okay. So find number of employees. Find the employees, find number of employees. Okay, so that's simple. So we do not need to say for department. So the case will be simple. So basically we are using all data, no selection of cases. So we do, that's number of employees, that's count. So we say the count, okay? So what do we count? So after the count, usually after the group functions, you usually specify columns, okay? Which column you're going to use for statistical calculation, okay? So for this count, we actually just count the number of records, right? So we can just count, say star. Star means all, just entire record from EMP. Okay. Simple as that. So in total, I have 17 employees. You may have different ones, okay? Now let's continue that. Let's say this time I want to find total salary of all employees. So again, there's no selection of cases. So we basically just need to find a total salary. So what is that? That is select what? Select the sum of cell from EMP. Okay. So you say that if you're doing that if you're going to do statistics package, you're going to click here, click here, click here. So here, just one simple command. You can get everything. Okay. All right, so I want you to do the same thing. Can you find what is the minimum salary for the company? Got it? What is the maximum salary? So select mean cell, run EMP. Okay, and the maximum salary, select max cell, run EMP. Okay, now let's say if I want to do get a statistic for all on salary for all those characteristics like a minimum, maximum, and average and the standard deviation. So let's just say all descriptive stat of salaries. Okay, for all employees. So in that case, I will do say mean of cell, max of cell, and then average of cell, and STD DEV actually, DEV of cell. Okay, so for EMP, so you get all basically 4 statistics in one place, one place. Okay. So you can do, this is just basically we're using salary, but you can use also other columns too. So for example, if I want to find out what is the most recent hire date among all employees, most recent ones, so that would be just say most recent hire date. So that is max, right? So select max hire date. And from EMP. So that'll give you what is the most recent hire date. Okay. And then is temping. Okay, now let's see. In this case, somebody say, I want to know who is that person who was hired most recently. So it's tempting to do something like this. Put your name here. Okay, and then if you run it, and you're going to get some kind of error like this. Can somebody explain to me why this is the case? You will get this error. Can you explain to me why you get this error? This will not work. Nobody knows? The simple answer is this. When you do statistics, you are getting only statistics. You will not be able to get individual records. So you're mixing the group characteristics. In this case, the entire company as one group, right? And then with individual characteristics, which is employee name. You cannot imagine this, can you? A group and also individuals. So if you're trying to find who has the most recent hire date, then you have to wait for next week, and I will show you how to get that. But this is not the right answer. Okay? So I'm going to give you, this is wrong case. So usually when you do group functions, then you have only, this inside select. After select statement, you have only group statistics, group characteristics, no individual characteristics. Okay, so just remember that. So let me write down here. So uname. Okay. So this is 1 because of mixing group characteristics with individual cases, individual records. Okay, so that is not allowed. Okay, is that clear? So basically for any column, you can apply, you can do group statistics. Okay, so now let's try to see what if I do select cases. So in that case, if you use jump or minitab or SPSs, you basically say I want to select cases and then specify the conditions for the cases to be selected. But here we are using where clause. Okay. So now let's say I want to find the total amount, the number of employees. I want to find the number of employees for employees hired after 1981. So find the number of employees hired after 1981. Okay, so let's do that. So select count again, count star from EMP. Okay, and now we have to select those employees, select those cases. So the hire date must be after 1981. So we can say after greater than, how do we say 1981? So we can do just using format, like I say December 31st, 1981, or we can just use to date, convert 1981 into date, 1981. Okay, and then the format is going to be year. Okay, there we go. So that will give you all the employees hired in 1981, after 1981, and then you count those number of employees. Okay, so it's 9 employees. Okay, now let's do it again. So this time I want to find total amount of salary, or let's say find average salary for salesman. Average salary for salesman. Average salary for salesman. Okay. Okay, so you need to use average cell. Okay, from EMP. Okay, and then say well, job is equal to salesman. Okay. Now, I don't know whether I mentioned that. So it's because all the case because of case sensitivity for text data. So things inside single quote like text is case sensitive. So if you misspelled, like if you spelled as a small case or mixed case, then you're not going to get the result, right? So if you do want to handle all the cases, then you can just convert that. So for example, I want to convert uppercase job title with uppercase salesman. Okay. So in that case, whatever inside the single quote can be in any spellings. It does not have to be capital case. Okay, salesman. Okay. So this is the function. Upper, lower will help you to handle those case conversions. Okay. So let me comment here. Upper and lower allows you to do those case conversions. Okay, let me write down here. Okay. All right, so now let's see that, and we'll run it, and then we get average salary for those salesmen as $1,400 average salary. Okay. Okay, let's do one more case selection. This time, let's say I want to find out maximum and minimum salary for employees in Dallas. max and min salary for employees in dollars. Okay, so you understand that dollars is location is inside the department table. So therefore, in this case, we have to use a join, right? So I'll do select max of cell and then min of cell. Okay, from what? So we have to use join. So let's say DEPT, join EMP, say on what? On the criteria department number equals to emp.dept number. Okay, so after that just created like a temporary table. So you understand that this case is more powerful than your cells, your mini-table packages, because it allows you to create a temporary table to do analysis. Okay, and now let's say where class, where location equals to dollars. Okay. All right, so this is the maximum, this is the minimum for people in dollars. Does it make sense? Does anybody have questions at this point? No questions? Now, if there's no questions, let's take a shorter break. Let's take a break until 8:15, okay? 8:15. Let me stop recording for a second. Is everything okay? All right. Is everyone's here, right?
Yes.
Okay. Now let's resume. So we did both case 1 and case 2. So basically, we do new case selection, do those statistics, and then we select cases. We use a where clause, and then now let's do something similar to factor analysis. Basically, we're going to group those cases into different groups, and then we find the statistics inside each group. Okay, so let's start with simple example here. So let's say I want to find the average salary of each department. Find the average salary of each department. So let me do. So let me see. Do I need this one? I can close this whiteboard. Okay. What is this? Where did I come up with this one? It's some kind of like some books about I don't know where. Let's close this one. Close this. So this is not from anywhere. I don't know where it's coming from. Okay, so let's copy that question first. So find average salary of each department. So apparently you want to see the employee salary, right? Average employee salary for each department. So we are going to do select AVG of cell, okay? And the data source, in this case, simple table, one table is enough, EMP table, okay? And then do we select cases? No, because there's no case basically we say we are going to put all cases in the different departments, but we don't select any cases, right? So we will directly go to group by, okay? Group by, so what do we group by? We group by department name, right? Because, no, not department name, department number only, because the EMP table has only department number, no department name. So if we want to do department name, then we have to do a little bit different. So we have to use a join. So let's do department number first, department number, okay? And then let's run that. Okay, so here we get average salaries, but this one department does not have anybody, no employees, I guess, right? And then this is what? This average salary, the average salary. So it would be nice to show not only this average salary, but also department number along with it. So we put a department number here. And then I said, you cannot mix group functions, group statistics with individual characteristics. Is this department number individuals or group statistics? Group characteristics or individual characteristics? What do you think? So average is, of course, for the group. Is department number is a group for group also? Yes, it is actually, because you already put the employees in the different departments by their department numbers, right? So each group will be labeled by department number. So you can show that group label along with the group statistics. That's okay. So that's actually the only case that you are allowed to use individual columns inside along with group functions. Along with group functions or statistic functions, you can have columns, and those columns must be the ones after group by. When you use group by, use the column to do groupings, and those column names, column values will be like a label for each group, and then you can show the label along with group statistics. So this is the only case which is okay. Okay, so let's just run that, and then let me write that, write what I said here. So no columns are allowed with group with stat functions, except for ones after group by. So this is the only exception here, okay? So if you use a group by, for example, group by department, group by job, group by something else, and only those columns, if you have multiple group based on multiple columns, for example, group by gender, department number, or job, so you can just list those columns along with statistical functions, okay? So this is one exception for the ones I think I mentioned before, that you cannot mix individual group characteristics with individual characteristics, but this group number is not individual characteristics. This number is, department number is group label, right? Okay. All right, so now this is, let's use this example to do a few more examples, okay? Use this as a template to do few more examples, okay? First, I want you to find out what is the maximum salary for each job. Maximum salary for each job. So I'll give you 2 minutes, and then you just trying to use this template to create this query. Are you done? So let's do it together. So we'll say select max of cell, and then job from EMP, and then group by job, right? So it's pretty simple, right? Just like that. Okay. Next, let's try and find total number of employees hired each year. total number of employees hired each year. Okay, so this time whenever you say each, okay, so you basically need to group by, right? Group by year, group by job, group by department number. So let me just come back to this one. If you want to do department name to do groupings, then this is what you have to do. Okay, say select AVG of cell, okay, and then dname from, so we are getting salary and the department, so of course we are going to join, so do DPT, join EMP, and then say on dpt.dpt number equals to emp.dpt number. Okay, and then we do group by dname. Okay, so this time the group label is department names. Group label is department names, but you cannot change the department number here. So if you do dpt number, because you have confusion, right? Because department number is a column in department and also EMP table. So you have to specify which column you're talking about. If column name does not have confusion, then just reference the column name without putting table name in front of it. Okay, so if we do department number as for grouping, then the label has to be changed here also. So we have to use department number.dpt number. Okay, even though you are using department number for grouping, but since you joined, but that does not change the fact that the label, this label has to be consistent. Okay, this group label and that group label must be the same. So you cannot change. So if you want to change it to dname, back to dname, okay, then this has to be back to dname. Okay, so now let's come back to this question. So this time I want to find the total number of employees, So that's count hired each year. So we need a group by year, right? So we're going to do select, count. Okay, so how do we do year? So we do to char, and then hire date, right? And then we say year, y. Okay, and then from EMP, and then group by, let's say group by to char, hire date, y. Okay, got that? Okay, now I'm asking you to do one similar to that. That is find total number of employees. Somebody have questions? Hired each month.
Yes, Professor, I have a question.
Yeah.
It says total number of employees, so can't we use sum of star instead of count?
Oh, no. Because
Okay.
we are talking about total number of employees, so actually we count number
Okay.
1, 2, 3, right?
Got it.
Some will be just simply add those numbers. So for example, we can add salaries together, but we cannot add employee numbers together, can we? We cannot, right?
Okay. Yeah.
Yeah.
Got it.
All right, so to the next question, find the number of employees hired each month. Just pretty much similar to the one we just did. Did you get it? So in this case, we are going to select by month. Select, count, okay, and also to char. Okay, so how do we say month? So you can use a month name or just a month number, MN, or use the first 3 letters of a month name. Either way, okay. From MP, then group by to char, then hire date, then month. So have to be exactly the same. Then you cannot change to month name, and then this is the abbreviation, or this is the month number, and this is the month name. You cannot do that, okay? So this label, the group label must be consistent. Okay, so now let's say we get November. So that includes all November of all years, okay? 1 employee hired, February 2, okay? Okay, December 3. So let me open up open-ended question here. Which month the company hired the most employees? Which month the company hired the most employees? So I will leave that as open question for you to think about after the class, okay? All right, now let's do one more with cases. So this time, let's say I want to do what? I want to find total. Let's find the standard deviation of salaries for each location. So let's say which location has some higher salary differences than other locations. Okay. So question is find standard deviation of salaries for of employees for each location. Okay. So we know what stat we want. That is, we want to find standard deviation, salary STDDEV of salary. And also we need location, okay? So from salary, EMP table, location from other tables, so we need to use join, okay? EPD, inner join, and then EMP on equals to EMP.EPD number, okay? And then we say group by what? Group by location. So now let's see. So which location has higher standard deviation? New York, right? Dallas second. Chicago is third. And this department has no. There's one department has no employees, I think, right? Yeah. Okay, so this is how we do what? Dividing cases or do factor analysis. When you do factor analysis, you can also select select cases. You don't have to use all cases. We have been using all the cases here, right? So let's just try to do one with selecting cases. Let's say I want to find number of employees hired after 1982 for each department. Okay. So what we're looking for, number of employees, so that's count. Okay. So depending on the department, if we use department number, then the only table we need is employee table. So just use employee table, okay? And then we are not using all the employees. We only find employees hired after 1982. So we have to say where higher than after, that means greater than 1982. So I'm going to do what? So December 31st, 1982, like that, okay? And then we do group by DEPT number. Okay, so you can also select in cases when you do factor analysis. Does it make sense? So the count, and then this, so if we put a department number along with it, the PD number along with it, then we should get a department number and also the count. So 2 employees has no department, then department 20, 2 employees, department 50 has 1 employee, and all those employees are hired after 1982. Okay. Okay, does it make sense? Okay, so now let's do 2-factor analysis. Suppose I want to find out average salary of employees for each combination of a job and the department. So looking at the job, not just department, but also their but not only department, but also their job title to see whether there's any difference between those average salaries. So let's do select AVG of cell from EMP, and then we are not selecting cases. That's a group by DEPD number and also job title, both. So this is more like a 2-factor analysis, okay? And then because we select these 2, use department number and the job title as a label, so we can actually list both of them here. Okay. So let me put a question here. Find average salaries for job department combination for each job department pair, okay, pair, something like that, okay. So let's run that. So you get that. So department 20 manager, average salary is that, and then for department 30 manager, average salary is that. So if you look at also like a standard deviation, then you basically just make some kind of hypothesis testing to see whether the managers have different salaries, different average salaries. Okay, so maybe certain department managers have higher salaries than others. So this is really like a like a t-test, right? Okay. So with the 2-factor analysis, you can do not only 2, but also more, and also you can select cases. Okay. So for example, I want to find those job department pair only for employees hired before 1990, something like that. So if that is the case, then we just need to add where hire date before, so less than 1983. So let's just do before. So therefore, January 01, January 1984, something like that. Okay, not here. Semicolon is not here. So you can select cases. Salary, find average salaries for each job department pair among employees hired before 1984. So let's also update the question here. So run that, and then you get a different result here, right? So now you say managers, and then manager here, clerk here, clerk here. So they have a different average salaries. Okay. So this is how we do. So basically, case 3. That is, you do statistical factor analysis type of queries. And now let's try to come back to our examples. Let's try to finish those examples before the end of the class. Okay. So next one, find the department whose minimum salary is less than. Okay. So now let's do case 4. That is, we are going to use group statistics to search for groups. Okay. Example 3. Okay. So we are looking for departments with a minimum salary. So minimum salary, remember that is statistics, right? So remember when the question is reference to any of these groups or any statistic functions, then just remember you need to use statistic functions. You probably need to use a group by. And here you're looking for department. So let's just do the question step by step, okay? So suppose I'm going to just say, show department number only. So you can get the department name, okay? But then you have to do join. But let's just get department number to be simple. And then in that case, I'm going to use EMP table, should be enough, right? Okay. And then we need to ask, are we going to select cases in this question? Does it specify which employee, what type of cases we are going to use for statistics? It does not. So basically, we are going to use all cases. So there's no where clause. But then, are we going to use a group by? Of course, we are actually group those. We need to use statistics, right? We need to do statistics. So when we do statistics, use statistic to do to select groups. Then we have to use group by, right? So group by the EPD number, okay? And then how do we say the minimum salary? So minimum salary is less than 500. I don't think anybody has less than 500. So let's just change that to 800, to 900, okay, to 900. So to do that, you use another class called heaven. And then in the heaven class, you just list the group statistic conditions, okay? So that in this case, is a minimum salary is less than 900, something like that. Okay, so department 20 is the one. Does everybody get that? Okay, so now I'm going to ask you to continue this kind of example as this a sample to do a few more examples. So this time I want to find the departments that has less than 3 employees. Can you do it? I'll give you 2 minutes. Find the departments that has less than 3 employees. Do you get it? Has anybody finished it? So let's do it together. So we are going to select department again. But let's say we want to do department name or department number. Department name. Okay, let's do department name here. D name. So department name, since we are going to use count employees, so we need an employee table, and also we need a D name, which is the department table. So we have to join from inner join emp equals to emp.depd number. Okay. And then we do group by D name, right? Okay. And then we say heaven count is how many? Less than 3, so less than 3. Okay. Okay, let's see which department? Production, production one. Okay. And let's do it again. So this time, let's say I want to find the location. find the location that has maximum salary, that have maximum salary over 2,000. Find the location that has max salary over 2,000. Okay. So again, we are looking for location from salary from EMP table. So we are going to do join again. EPD inner join, and then EMP, then okay. And then we do group by location. Group by location, and then heaven. So this time we do max cell, maximum cell is over 2,000, so greater than 2,000. Okay. So those locations, 3 locations, all have that, all meet that criteria. Maximum salary over 2,000. Okay. Now let's do one more. Find the year, the company hired hired how many? 2 hired 2 or more employees. Hired 2 or more employees. So it means the count should be greater than 2. So you do that. 2 minutes. Okay, do you get it? So say you're going to do find year, so 2 char. Okay, then that is hire date. Y. Okay, from EMP, and then group by 2 char also. Okay, and then we say heaven. So this time we say count is over 2. So count of number of employees is more than 2. 2 or more, so 2 or equal to, and greater than or equal to 2. So 1987, 2020, and 1981. All right. Does anybody have questions about the group selection? So let's try to see whether there is any other questions here. We can just finish them quickly. So this is actually something you should be able to do it. Question number 4. Find the job categories whose average salary is more than 2,000. Do that quickly. Okay, if you can do it, then I can skip that. I don't have to repeat. So it's just either looking for job, select job, run EMP, group by job, heaven. So basically we are talking about average salary. So average cell is more than 2,000. Okay. So let's see which jobs have that average salary. We find the president, the manager, and the analyst. So that's pretty simple. And now let's say this time, let's say I want to find most recent employment. So that's basically hire date. That's a maximum hire date. Among those hired before 1980, I don't think we have anybody like that for each department. So for each department, you need to group by department, right? And then employees hired before 1980, so that is actually selecting cases. So you need to use a where clause to do that. And then you need to find a maximum hire date, right? So that is something we did before. So let's do max hire date. Okay. And then from EMP. And then we need to select cases. So hire date is before, so less than 1980. Before 1980, so January 1st, 1980. 1980, okay? And then we do group by DPT number. Nobody. No departments, actually. No department, no employees, actually. We don't have any employees hired before 1980, okay? So when we get into this, I'm going to explain 2 rules about SQL statements, programming rules, okay? So it's just like when you're playing games, you have to follow rules, right? So here we have a couple of rules here. The first rule is result does not count, okay? What matters is the logic, the program matters. So what does that mean is that if you, for example, somehow you say you write SQL statement, you get the same result as the one, even though the SQL statement is incorrect, but you get the same result as the one which is correct, does not mean that your SQL statement is correct. Okay, because we have to consider that if you apply, or if I apply your SQL statement to different data set, to different kind of database, then your result, your incorrect statement will get the wrong result. Okay, so this is that's rule number 1. Just make sure you understand that. Okay. So if you sometimes sometimes especially with some students trying to argue that their statement get the same result as the one which is, even though the statement is incorrect, but get the same result as the correct one, but that does not mean that your statement is correct. Okay. Second rule you need to remember is one query, one statement. What does it mean? You cannot create, say, for example, for some problems, you cannot write one statement to fulfill the query requirement. However, you write 2 or more statements to achieve the same result. But that does not count. You have to use one statement. You cannot use multiple statements to accomplish one query. Why? In a simple way, you can say that is the way, that's the rule. That's the way, that's the game of the rule. Another more pragmatic justification is that if a statement can be written in 2 statements, then it can be written in 10 statements or 100 statements. So something which we can do, you can do just in 1 second, maybe just no second, and then you have the right, you write many different statements running that statements in a lot of times. So that is not very efficient. Okay, so one query, one statement. Always remember that. So if I give you a question, you have to have just give me one statement, one SQL statement. You cannot give me two more statements. Say you use that two or three statements to achieve the same result. That will not be. That is not. That will not work. Okay. So. So basically, that that's that the rule this is kind of you can just say this is like a playing game. And then I will give you number 3 rule. It's kind of related to number 2. That is query statement must be based on the given data. Okay, do not assume data beyond what is given. Okay, so for example, if I ask you to find out say what is average salary for sales department? So what is given is that the department name is sales. Okay, so you cannot assume that the sales department has department number 20, and then use department 20 to replace sales department name for your query. So you have to make the right statement based on what is given. Do not assume that you can look up data and then use that data to do whatever or statistics to do the query, and then use that query to assume that is one to fulfill the requirement of original query. That is not allowed. Okay, so if I think of any other rules along the way, I will let you know. But for now, I can tell you that those 3 rules you should remember. Okay, so that's based on this question we just did. Say this one give you select just say find a no result. And that's because in my data set, I do not have anybody hired before 1980. Okay, even the statement is correct, but the result, does not really matter in this case. Okay. All right, now let's.
Professor,
Yeah.
can you repeat the example for the 3rd rule again?
So the rule. So based this, when you write SQL statement, so make sure you use what is given. The data is given, and do not assume any data. Okay, so let me repeat the same example. Suppose I want you to find out what is average. Let's just do that. Okay, find average salary for sales department. Okay, so in this case, what are given is the department name is sales, and I did not give you department number. So if you say the department number, so I can find out what's department number, right? So select star from DEPD. Okay. So the sales department is department 30. So if you assume that the department number is 30, so you're trying to do this query like this, average salary, and then from EMP, and then say where DEPD number equals to 30. And even though the result is exactly the same, right? Result is correct. However, this is the wrong statement because you are assuming this 30, which was not given in this question. Does it make sense? Okay. So this is wrong. So what you should do is instead you should do average sale from. So we are using department name, so we have to use EMP, join maybe DEPD on equals to EMP DEPD number. Okay, and then we say where location D name equals to sales. So that would be the correct one because we are writing query based on what is given.
Okay.
Okay.
Thank you.
Yeah, no problem. Anybody else has a question? Okay, if no questions, let's move on. I think we have two more, and then we should be able to finish on time. Okay, so next question. Okay. What is this? I select only. Okay, select that. Oh, this one. Oh, I select both two questions. So let's just get rid of that. So this one was wrong. Okay. So find average salary of those employees whose name starts with J in each department. So we are doing average salary, and then employees whose name starts with letter J. So you can tell that this is what? Selecting cases, right? Selecting cases. And then for each department. Okay. So select average cell from EMP, and then we say ename like. So has a letter J, starts with letter J. So J and the percentage sign like that, right? And then we do group by DEPT number. Okay, make sense? So this is actually something we did before, just like a factor analysis involving selecting cases. You select cases and then you group by, right? So that is not new. Okay. And then finally, one more question here. Okay. And then this time we find the job categories. And the job category whose maximum salary among the people hired after 1980 is more than $2,500. So let's analyze the question here, okay? So we are looking for job, okay? So if that's the case, we could looking for individual records, okay? Because each employee has a job, right? And also we could looking for groups. So we can group by job and then use group statistics to decide which job will be selected. Does it make sense? So that is says that's undetermined. So we will write that first, select job. Okay. From that the data source is probably a little bit easy to decide. So depending on the question, whether the question reference to any other tables. So in this case, I don't think so because we are looking for hire date and the salary. Okay, so basically EMP table should be enough, right? Good. All right, so that after that we need to decide: are we doing group? Are we selecting cases or not? So let's say we are selecting cases. Are we? People hired after 1980. Yes, we do need selecting cases. So we are using where clause. Okay. So where hire date after 1980. So let's use to date. And then y. That's 1980. Oh, sorry, 1980. Sorry. Hire date in 1980. So you need to change 1980 into hire date. So 1980. Okay. So a single quote. So basically, this to date will convert this text into your number here. Okay. And then we need to decide if this now we need to decide whether you are selecting groups or selecting individual job titles. Okay, so here we need to look for more information. So first we're looking for maximum salary. Okay, more than 2,500. So because of that, we need to use group. We need to select job as a group. So we are going to do group by job. And then we say having maximum salary. So you know that individuals does not have maximum salary. Only the group has maximum salary, right? So anything related to group functions, statistic functions, has to be applied to groups. Okay, so that's why we need to use group by. Okay, like that. Okay, and run it. So we get those. There's one more class, so basically 1, 2, 3, 4, 5. So actually, if we make it complete, the one more class, which is order by is just simply sorting the result. So if I want to sort job title, so group by, so order by job title. And then we can also decide whether we want in ascending order or descending order. And by default, it's ascending, ASC. As is ascending order. But if you want to specify, say I want to do descending order, so largest job title, so they basically just alphabetical orders, right? So A, B, C, D, Z. So Z will be first, and then back order. So that in that case we'll say D, E, S, C, descending order. Okay. So then we have a complete sentence, the syntax for select statement. Okay, select group functions or individual columns or like a column, like a group labels, from name of tables, and then selecting cases, and then group by, how do you want to divide the cases, and then which cases, which groups will be selected, selecting conditions for selecting groups, and then order the result, sort the result. Okay, so that is complete sentence like that. So you say that P, M, and A, so that is in descending order, right? Okay. All right, we have about 10 minutes left. So in this 10 minutes, I don't think I need to, there's nothing to, no, I don't think I need to give you anything new, just beyond this. Just look at your homework questions. So this time you have like a 28 statements to write. So basically, it's kind of like a lot. However, you will probably find out that a lot of questions we already did in class. Okay, for example, find the total salary for each job, and then find the department that has less than 5 employees. So a lot of things we already did in class. So I want you to have this second opportunity to practice all these queries again. Okay, don't just look for answers, look for examples, trying to answer these questions yourself and see whether you can do it without using the examples. Okay, the point here is only through that you practice your database programming skills. Okay, so I don't. So here there's a total annual pay. So that basically salary plus commission for each employees. So in this case, are you? So let's try to do this question, okay? So first of all, salary plus salary times 12, that should be okay. But then the commission, some commissions are what? Are missing, right? So some commissions are missing values. So if you use missing values plus that, you're going to get a wrong result. Okay, so you need to handle that. And then here, say for each employee, are we doing group or doing individuals? Do we use group by? Each employee is one case, right? So you really don't, even though this time says for each employee, but you do not need to use group by, because you are just basically each employee is one case. So you are doing something basically just regular, just simple statement. Okay, so select 12 multiplied by salary plus commission. Okay, so you need to handle that, okay, from ENP. So that is what you're looking for, okay? So so if you do something like a group by what? Group by the employee number, ENP number. So that is same thing. That's you really basically each employee is going to have each employee is just one group, right? So this is not necessary. Okay, does it make sense? So you when I said that, so when you're looking for keywords like each, so you have to make sense. In this case, each employee is just one case. So there's no group, right? No need for group. Each employee is just one group, right? But in some other cases, like for each job, then of course many employees have the same job, so you need to put those employees into the job. And if say for each year, that each year has many employees, so you need to put all the employees hired each year into a different group, right? So sometimes each will make sense, but this case, each does not make sense. All right, anybody has questions? No questions? Right, if there's no questions, I will see you next Monday. Good night, everyone.